Hello students, welcome to the video class on Thermal Engineering Laboratory by Department of Mechanical Engineering, TKM College of Engineering. Experiment number 2, heat transfer through composite walls. So here we will be determining the conduction heat transfer to different types of materials and find their thermal conductivity and the resistance offered to heat transfer. So in the theory, we have assumed a one-dimensional steady-state heat conduction here, and there is a heater in the middle of these different materials, and heat will be conducted. There is a copper plate in between. There are two copper plates in between. There is a heater, and it will be heated, and heat will be conducted from the copper to mild steel, wood, and alum. Now these are the precautions that we need to follow. As a procedure, we need to start the AC power, which is the input heat energy to the heater, using a dimmer stat. So we will be measuring the temperature using thermocouples, and this is the plate dimensions. The diameters are same, but the thicknesses are varying. Now this is the actual setup. You can see these plates are circular in nature, so with the same diameter. The color difference shows different types of materials. The copper is in the middle, two copper plates. We have the heater in between. The heater is heated up, the copper gets heated up, and correspondingly heat will be conducted in two directions, up and down. So heat will be conducted from copper to mild steel to wood, and from wood to the alum. And corresponding the temperature will be varying because of this conduction, the resistance to this conduction heat transfer. Now in the experimental setup, we have a different instruments shown there. We have a dimmer stat which will be varying to change the input energy and the heat, and it will be can be read from the voltmeter and the ammeter, and we have also the temperature selected to see the temperature different points. T1 and T2 will give us the average, will give us the copper temperature. T3 and T4 gives us the mild steel temperature. T5 and T6 will give us the wood temperature, and T7 and T8 will give us the alum temperature average. Now to start the experiment, we need to switch on the heater from off to on position, but since we have not given any volt in the dimmer stat, the temperature will be the same as the ambient condition at all the points. So these temperatures will be given, will be changing only when we are varying the heat input. So to start the experiment, we need to give a particular heat input so that the temperatures at these points will be varying. So here you can see the meter and voltmeter values are 0, and now we will start giving some heat input. So the voltage is being increased to about 100-110 volt, and correspondingly the ampere will be increasing, and Vi cos theta will be giving the electrical energy input, and we assume that all the electric energy is converted to heat energy, and these values are noted down along with these temperatures. We need to wait for steady state to be achieved, so that temperature at a particular point will not be varying with time. So the time interval based 10 to 15 interval based marking of these temperatures from T1 to T8 will be done in this tabular column. Now when we can see that when we vary the temperatures, this temperatures at different points will be varying because heat will be conducted from the copper through the mild steel, wood, and alum, but the resistance to this heat transfer will be different. It depends upon the surface area, which is actually constant here, the thickness, and as well as the conductivity. The thickness values we know here. You can see the temperature varying at different points because of this thermal resistance offered by these materials. Now the temperatures, you can see that it's varying from about 107 or 108 degree to 42 degree, depending upon the resistance in each layer. So here it is 107 degree, 108 degree for the copper plate, and then it is mild steel, which is about 103 degree. Then it crosses the mild steel and goes to the wood, which is about 60-65 degree, and from the wood it goes to the alum plate, which is about 50 to 40 degree, and we will make sure that the steady state is achieved for the final set of readings. Now once the final set of readings are achieved, we have received the values. We will use that to calculate the equations to find out this. Now, so before we switch off, we put the dimmer stat to 0. Make sure that the voltage and ampere is 0 and we switch off the elements. Thank you.